This project attempts to reproduce the results in Greenwald's paper on correlated Q-learning. The task is to simulate a two-player soccer game using the 4 multi-agent Q-learning algorithms listed below. Shown here is a schematic of the soccer game. There are two players A and B who move in a 2x4 grid. The goal or destination for player A are the green cells on the left, while the goal for player B are the blue cells on the right. At any step, each player can take 5 actions. He can move north, south, east, west, or stick to the same cell. At each step, either player can move first with equal probability. In the event of a collision, the player who moves first prevails. Also, if a player with the ball moves second, then the ball changes position. The project was implemented in Burlap. Shown here is a sample episode visualization generated by modifying the Burlap grid game visualizer to suit this problem. Listed here are the parameters used in the simulation. The learning rate alpha is given by 1 by 1000 divided by 1000 plus t, and it was chosen so that alpha tends to 0.001 as t tends to 10 power 6. The value of the exploration parameter epsilon and its behavior was not known exactly, and therefore different values were used for different algorithms. This is not desirable, but was done in order to match the results obtained in the paper. Let us now look at the results. The results for the Q-learning algorithm follow the same trend as those seen in the paper. The decay in amplitude is not due to convergence, but due to the decaying learning rate. For FriendQ, the solution converges quickly, but is irrational because of the unreasonable assumption about the opponent's intentions. The results follow the same trend, but not the exact results in the paper. For 4Q, the results follow the same trend as in the paper, but because of the high epsilon value, there is noise even after many iterations. For correlated Q, the results were different from 4Q, and it converges very fast. And this could be possibly because there were convergence problems when using the Burlap linear programming package. Listed here are some of the challenges faced while implementing this project. In particular, the lack of sufficient information about the learning rate and the expression parameter resulted in differences. Also, there were convergence issues with the linear programming packages, as well as on using the 32-bit packages on a 64-bit computer.